All right, seventh graders, we are starting one of my favorite chapters, solving systems. Now, you're probably thinking, I have no clue what a system is. Before we do anything, I want you to look at a problem. X plus y equals, let's do 5. Give me solutions that make that true. Okay? So give me other solutions. 2, 3, 3, 2, 1, 4. Now, how many solutions are there that would make that equation true? Well, you could do things like 6 and -1. You could do -4 and 9. Now, if you graphed all of these, you would probably realize that you would get a line. What we are then going to do with this is solving systems. So basically, you are solving an equation. That's all you're doing. But you're solving a system. And a system means that you have to solve things like this. Let me erase this, put a minus. You now want to give me a value of x and a value of y that would make both equations true. Both of these. This one and this one. So, once again, there's an infinite number of solutions for each equation. But if you graph these equations, they are going to intersect at one point, and it is the one point that makes both of these equations true. And if you did this correctly, your answer is going to be that. 3.5 plus 1.5 would give us 5. In addition, 3.5 minus 1.5 would give us 2. So, what are you going to learn today? You're going to learn how to check solutions, that's easy, solving systems by graphing, and using them in real-life problems. So, write this down. A system of linear equations is a set of 2 or more linear equations in the same variables. So in example 1, example 2, so these are two equations with the same variables. So this is a system of linear equations. The solution of a system of linear equations in two variables is an ordered pair. So the answer to this system would be an ordered pair that would satisfy both equations. Now, step 1 is going to be easy peasy. Step 1, I want you to check to see if it's a solution. So they're going to give you an ordered pair, 2, 5. And they want to know, is that ordered pair a solution to both equations? Well, you plug them in. So if I plug in 2 plus 5 equals 7, the first one is true. The second one, 2 multiplied by 2 minus 3 times 5 equals -11. That is 4 minus 15, which is -11. This one is yes, it is a solution. The second one, let's plug them in. 0 equals -2 multiplied by -2 minus 4. That gives us 4 minus 4. First one is true. The second one, 0 equals -2 plus 4. Nope, that is not true. So the second one, -2, 0, is not a solution. So the first part of this, really easy. Now, solving systems. So how do you do it? Pretty easy. The solution of a system of linear equations is the point of intersection. Now let's just not even think about anything else on this page. Could you have a system where nothing intersects? Yes. What kind of lines would never intersect? Good, parallel lines. So guess what the solution would be to parallel lines? No solution. If you have the exact same line, for example, I'm just going to write this down. X plus 2 equals y. And let's do 2x plus 4 equals 2y. You will notice that these equations are exactly the same thing. All I have done is taken my first equation, multiplied it by 2. If you graph them, they would be the exact same line. Therefore, what part of the lines would intersect? It would all intersect. Therefore, you have infinitely many solutions. All right, so here's what we're going to do. To solve a system by graphing, you're going to graph each line, graph each equation. You're going to estimate the point of intersection. Now, here's the bad news. You have to be 100% accurate when graphing them. You must use a ruler, you must use a ruler, you must use a ruler, or a straight edge. Because if you are off at all, you're going to have no idea what the point of intersection is. Then you must check that point. If that point, when you plug in, is not a solution, you don't have the correct point. So let's look at example 2. Solve this system of equations by graphing. So all you're going to do, now, stand back, and let's, before we begin, go over how we can graph. If you want to make a t-table, make a t-table. If you want to use slope-intercept form, use slope-intercept form. If you want to solve using intercepts, solve using intercepts. It does not matter. So here we go. I'm not going to go over how to graph because you know how to graph. If I graph both of these, the graph is going to appear in about 10 seconds. If you graph them both, bam, there it is. Pretty easy. These I would graph using slope and y-intercept. Here it is. As you can see, there's one line, there's the other, and there's the point of intersection. If you took the point 1, 3 and plugged them in, it would work. So 1, 3 is the solution to this system of linear equations. So now we're going to solve a real-life problem. A roofing contractor buys 30 bundles of shingles and 4 rolls of roofing paper for $10.40. In the second purchase at the same prices, the contractor buys 8 bundles of shingles for $256. Find the price per bundle of shingles and the price per roll of roofing paper. Now you can use whatever letter you would like. I'm going to use X and Y. I'm going to say X is shingles and Y is roofing paper. So 30 bundles of shingles plus 4 rolls of roofing paper equals $1,040. Now in the second purchase using the same prices, the contractor buys 8 bundles of shingles for $256. So 8 bundles of shingles, that would be 8x, $256. Now you may ask yourself, Mr. Humphreys, why don't I just divide by 8, get the value of x and plug it in and go from there? You could do that. But I'm going to go over graphing just to show you what it looks like when you graph. Now, in this problem, what I would do, if I was graphing this, I would solve, let's see, I'm going to actually take this one right here, and I would solve it for either y, or I would find intercepts and do the x-intercept and y-intercept and graph it like that. This one, I would just divide both sides by 8 and get x equals, I think it's 32. Is that right? And 24, yep, that's right. So then I would just graph the vertical line x equals 32. So I'm going to pop up the graphs. Once again, I'm not taking the time to go over how to graph because by now you should know how to do that. Make sure your graphs are accurate. Your graphs need to be accurate. A little bit of a mistake there, but here we go. You will notice that we cannot have a negative amount. So my graphs don't go below the x or to the left of y. If I solve this one, you would get y equals negative 7.5x plus 260 if you solved it for y, and x equals 32 as a vertical line. Now, you will notice that it is not as easy to find a point. For example, 32 is easy, but 20. Could this be 21? Could this be 25? We don't know. So this is why you have to be accurate. You can graph the point and then plug it in and check it, and it does work. So 32, 20. But make sure you put real-life problems with real-life answers. The price per bundle of shingles. Well, it was $32 for the bundle of shingles. And it is $20 for Y of, which is roofing paper. Roofing paper. There we go. And there's my answer.